Hey there. So I had several students ask me about this problem, so I thought we could do it together. I'm going to do the example that's like this, and you can follow along for the example and then um, go from there to do your problem. So it says for a multi-state lottery, the following probability distribution represents the cash prizes of the lottery with their corresponding probabilities. If the grand prize is 13 million, find and interpret the expected cash prize. If a ticket costs $1, what is your expected profit? Okay, so there's asking a couple different questions. It wants you to find and interpret the expected cash prize. That's how much money you expect to win. And then it's saying if it costs $1, what's your expected profit? So that's two different things. So we're going to start with the expected cash prize. And I'm going to show this with Excel because it's very fast with Excel. I will also show it with the calculator, I believe. So I just copied. I used the little copy to the clipboard. And if you had the ability to connect your calculator to the computer, then you could actually copy it to a comma file and a comma delimited file and stuff like that. But we're not going to worry about that. Okay, so here is this lovely table. Beautiful. So we want the cash prize. So expected cash prize. Okay, so the cash prize is what you have here in your X column right here. So that's cool. So, and luckily for you, I don't really want this to be equal to this, but these probabilities, because they're probabilities, must sum to 1. So your mean is actually the sum product of array number 1, comma, array number 2. Done. 29 cents. That's it. So again, sum product takes the sum of this cell A2 times B2, A3 times B3, or A4 times B4, and so on. And you would add them all up. It sums them. And because the probabilities add to 1, you don't have to worry about the division part for the mean because it's just divided by 1. So there's your expected cash prize. All right, let me show you what that would be like with a calculator. Hold on, let me pull up a calculator. There it is. Okay, so let me pull it over here. We want stat, edit. I'll clear out my old lists. I mean, this is one time where, man, Excel's a lot easier. Okay, so then you just got to type 13 million 200,000 and so on. 10,000. All right, let me pause and I'm going to type all this stuff in. Boy, this takes a while. If you want to kind of make your life go easier, you can type 1.745 E negative 6. Enter, like that. You can see it'll have it correctly. At least it should. And that was 3.7 E negative 7 and so on. There we go. I got my last one typed in. It takes a while. All right, then you go to stat, calc, one variable. Now I'm on the old system, so I have to do L1, comma, L2. If you're on the new system, then it'll ask you what your list is, you tell it L1, and what your frequency list is, you tell it L2. Oh, and I've done something wrong because I didn't get the same numbers. All right, let me double check. All right, I think I fixed it. Let me try it again. Stat, calc, one variable, L1, comma, L2. There we go. Sorry, I had my probabilities typed in wrong. So many decimal places. Okay, so the other thing to keep in mind, like I said before, I can't show you, but if you have the newest system, like the brand new calculators, it'll ask you, what's your list? You tell it L1. What's your freq list? F-R-E-Q list. That's L2. And then you go down to the calculate and press enter. So you can get it so the blinky cursor is on calculate and press enter. You should get the same numbers we get. And the calculator here is much more tedious, but that's how it is. Okay, so then, let's see, we answered that question. Let's see if I'm right. See, 29 cents. Cool. Now they want to know the expected profit. So that was the expected cash value. So you can see they're telling you the expected profit is negative 71. So how do you figure that out? Well, you can do it a couple ways, but the simplest way is to say, well, if the ticket cost $1, then they would expect to make 29 cents on the prize, but take away $1 that they spent to pay for it, and that means they'd be at negative 71. And honestly, both of these should be formulated as currency because that's what they are. They're money. Okay? So you expect to make 29 cents in a prize, but you spent to pay $1. So $1 from 29 cents prize makes 71 cents. The other way to figure it, which is actually pretty simple, let me copy and paste all this over. Okay, so the thing is that your profit is what your cash prize is, take away $1. So if I take 13 million, take away $1, and I do that for all of it, so -1 and so on. And then I don't need this part anymore because look at that. It already figured out my expected profit. But when I do that, this is no longer a cash prize column. This is a profit column. Right? Because if you spent $1 to play, then if you win nothing, you're at -1 profit. If you win $3, then you're only at $2 profit because you spent $1 to play in the first place. See what I mean? And if you won $100, you only make 99 in profit. So this is the cash prize, this is the profit. So you could either take the cash prize expected value and take away 1, or you could figure out the different profit values for each one. Either way will work. And if you're going to use a calculator, you would just go in and figure out the new L1 values. You could even put them in L3 so you don't have to do it. Matter of fact, I'll be really tricky on you. You ready for this? All right, so I want to take this L1, 13 million and so on, and I want to subtract away $1. So if I take L1, oh no, I can't. Sorry, it won't work. I just remembered why it won't work, so never mind. So you'd have to sit there and type them all in, or you could just use this little trick right here. So that gets you -71 cents. Sorry, I took a moment and I typed in the new values. Can you see them? -2, or excuse me, -1, 2, 3, 6. I put those in L3 for myself just so you can see. And then if you want to find one variable stats from that, you go stat, calc, one variable, but I would tell it, I'm going to be crafty, L3, comma, L2, because my X values now are actually in list 3, because that's where I put these profit values, but list 2 still had those probabilities. And there you go, -0.7099, -0.71. Right? So that's how to get the profit. Profit is different than cash value. Cash value is what you get when you win. That's the money that you get back in your hands, but it disregards the money you spent to play in the first place. Profit is what happens when you keep taking into account what you spent to play. Okay, for the next part, they want to the nearest million, how much should the grand prize be so that you can expect a profit? Assume nobody else wins so that you do not have to share the grand prize. Okay, so let me go back here for a second. So what they're saying is the rest of these, this 200,000 and all that, that's all set, right? None of that's going to change. But what can change is how much the big prize is. So what you can do is you can fiddle around with this. See what happens, right? See, now you'd be getting a cash prize of 0.32, right? So you can just sit there and trial and error, try things out, see what happens, right? Oh, now we're at -0.73. But that's kind of a klutzy way of doing it. Oops. Oh, sorry, I'm in the wrong space. And you'll be sitting there a while trying to figure out numbers, and it'll just be kind of a pain. So let me do something instead real quick. Let me find the expected profit without the grand prize, just for the heck of it. Let's see what the rest of this stuff adds up to. Okay, so I'm going to find equals the sum product of this part without that top row, like that. Okay, you with me? See, notice I changed it to 13 million, nothing happened, right? So if I don't if I don't have a grand prize in there, my expected profit is -0.79. Okay. All right, so that leads me to some algebra. Hold on. And by the way, I'm doing this with the profit because, hold on one second. I'm doing it with the profit because that's what they said. They said expected profit they want it to be equal to 0. Okay, so now what is expected profit? Expected profit is, let's see, let's call it the G for the grand prize. That's what they do in the notes. So G for the grand prize times its probability. You know, it's 6.17 E negative 9, or 09 if you like. Okay, plus 19999. Is that too many nines? No, that's not enough. Times 0.0000037 plus, right? And do you see what I'm doing? I'm multiplying all of these. So I'm saying, you know, okay, it's that grand prize, whatever that is. So if this was your grand prize, it'd be that, okay? And then you'd multiply it by the next thing over. And then you keep going and keep going and keep going all the way to dot, dot, dot. The last one, which would be -1 times its probability, 0.973706265. Okay. Now, what do the probabilities all sum to? Well, they all sum up to 1, so that's cool. We don't need to worry about that. Okay. But you know that you want this whole thing to be equal to 0. Right? You want the profit to be equal to 0. And a profit is expected value. This is the expected value. You take each profit value times its probability, profit value times probability, profit value, and then you add them all up. You divide them by the sum of the probabilities, which is 1. But we just figured out that all the rest of this, like this from 1999.99 over to -1, all makes negative 0.79, period. So you say, okay, I know that this is G being the grand prize amount, 6.17 E negative 09 plus negative 0.79. So I guess really it's really minus 0.79. Has to be equal to 0. Okay, I got rid of the division by 1 because anything divided by 1 is itself. Okay. Okay, so then G times this value has got to be equal to 0.79 because you add 0.79 to both sides, right? To get this negative 0.79 out of there, you add it to the left, but then you add it to the right to keep it balanced. And then to find what G is like your X. X, you know, it's what you're solving for, your grand prize. So if you like, you could put X in there. It's fine. Okay? You're going to divide both sides by that 0.617, blah, 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 blah. So 0.79 over 6.17 E negative whatever. Okay? So you make your calculator, computer, Excel, whatever, do that. So I can make Excel do it real quick. I would just take equals that negative 0.79 divided by that probability. And there you go. Oh, except it wouldn't be negative. Sorry. Technically, it's positive 0.79, right? So if I do a negative E11, that'll make it positive. But that's not really a big deal. And again, with a calculator, it's super simple. You just type 0.79 divided by, and then, oopsie, clear, 0.79 divided by, and then you'd have to type in 0.00000, that's 6 zeros, 7 zeros, 8 zeros, 617. There you go. That big, huge number. Okay? So it's kind of an algebra equation. Oopsie, sorry, I'm on the wrong thing. So it's algebra. You're just, you know, you make a big, huge equation and you solve it for your X value. Oops, so there it is. Now remember they said they wanted it to the nearest million. It says, you know, for the nearest million. Oh, see, look, we got the same number they did, 128,070,538. That's what we got. But then you got to round it because they said they want the nearest million. So that would be 129, comma 000, comma 000, right? You'd round it up. That's fine, to the nearest thing. And I put it in currency form because that's just how I feel like doing it. And sure enough, that's what they'll tell you. See, 129,000,000. So there the work is there. So again, you let X be the thing you don't know, and then you find the sum product for everything else with Excel, or you could do it with a calculator. Pretend that that part isn't there and find it. It was negative 0.79, and then use that in that equation to solve for the grand prize. And round it.